The Zap Pack is a device that is designed to facilitate power requirements for battery-operated devices. The pack consists of three major parts: the power supply unit, an adapter pack, and electrical connectors. With the combination of these three parts, the unit can provide constant power to any portable power tool. People who operate cordless tools will find the Zap Pack handy when their batteries run out of power. Now with the Zap Pack, one does not need to stop their project waiting for their batteries to charge. This cost-effective device can increase productivity for anyone using power tools. Yet another reason for having the pack would be to save money. Now using the Zap Pack, one does not need to purchase extra batteries or purchase multiple tools in cordless and corded form. This device will take one power tool and allow it to function as both a corded and cordless power tool. The following is the testing of the electrical output and the heat discharge of the Zap Pack.
This is the insulated box that they're going to test their machine at. Place it in here, and then they're going to record the increase in temperature, if any, and see if it is acceptable for their part. What are good results for the test?
Little heat.
Little heat is the answer. Okay, here's a close-up of connections. So it limits at 12.5, 12 amps. So it does it work?
Yeah.
Yes.
You're not reading
Test 1, cover off, air cooled. So what are you guys going to do for test number 2?
Yeah, so see how much heat sink or venting we possibly need. May need none, may need a lot.
The graph shows the increase in heat over time. This is later used to determine the size of venting holes for the Zap Pack's case. Solid modeling using the program SolidWorks was a major part of creating every aspect of the Zap Pack. In the beginning, the Zap Pack was designed for Porter Cable's 18-volt tool lineup, but because of supply problems, it was converted to fit Craftsman's 12-volt lineup. The power converter is housed in a rapid prototyped ABS plastic case. In production, a heat sink would be added for further heat dissipation. Strength testing was done at 8 pounds per inch to simulate being stepped on. The case reacted well, only allowing the bottom of the case to deform. Deformation testing shows only a 2 mm movement in the center of the case. SolidWorks shows us that the created battery replacement case will fit seamlessly into Craftsman's flashlight. Drop testing of the battery replacement case shows high resistance to breaking. To rapid prototype the Zap Pack's 2 cases, the use of Lorain County Community College's Fab Lab was used. 3D drawings were imported into a computer linked to the Dimension SST 1200ES. After computing how much material it would need for the part and support, it would begin layering ABS plastic to form the Zap Pack. After designing, producing, purchasing, and testing all of the necessary parts of the Zap Pack, it was finally constructed. Solder was used to connect all of the electrical components together. Once soldered, all the needed fasteners were installed, completing the Zap Pack.
$113.7.
Functional testing was then done to each tool to show that the Zap Pack would allow for continuous power through cutting, sanding, drilling, and screwing. When your batteries die, look into the light. Zap Pack.